So law of signs is what we're learning today. I'm not sure if you learned it before or not. We're to go spend 2 days on it. Tomorrow we'll talk about the tough case of law of signs. But what's unique about law of signs is it works with this kind of triangle. So normally sine, cosine, tangent, they only work with right triangles, and at least that's what we've had experience with. But now we're going to work with triangles that are not necessarily right triangles. So we're learning about the law of sines, and then eventually we'll learn about the law of cosines. These are actually used, you don't have to write this down, but they're used in surveying. If you've ever seen, new property, kind of like laying the land, kind of seeing its level, like what kinds of things like that. And navigation with GPS, use triangulation with your cell phone. That's always part of the way your phone works, actually, is using the GPS notion of that phone. Even I had a phone that didn't have data at all, and it still had GPS in there. I could still use I didn't have any data, and I'm still able to use some of the GPS features sometimes, which is kind of neat. Okay, so first, before we actually show you the law of signs, I'm going to kind of derive it. So you don't have to write this down for your notes, but I want you to know kind of where it comes from. This is basically using right triangle trig. You can say sine of A is opposite over hypotenuse, so H over C. Sine of C, that angle right there, is H over A. And what I'm going to do is solve each one of these for H. So if I solve for H, this will be H equals C times sine of A. And the way I did that is I just multiplied both sides by C there to get C out of the denominator. And with this one, I'm also going to solve that for H. So H equals, I'm going to multiply both sides by A. So A times sine of big C. So now what must be true here, if these are both equal to H, I can set this equal to this. That's what I'm going to do. So I'm going to say C times sine of A must equal A times sine of C. By the way, if you didn't know this, the capital letters indicate angles. The lowercase letters are the opposite side. So like big C is over there, little c is the opposite side, or H is the opposite side, depending on what you're looking at. But in a triangle, the lowercase letter is always the opposite side there. So let's divide by C here. Divide by C. Those nicely cancel there. We get sine of A equals A times sine of C divided by C. And then I'm going to divide by A here. So I'm going to divide by A over on this side, divide by A over here. This nicely cancels. And we get at least 2/3 of the law of sines. I just got to derive part of it. You could do that again to derive the other part. But when you see that does actually come from somewhere, actually, you will need your calculator in a minute. That's why I had the calculator up. Okay, so law of sines is, well, I guess I need to write down what the full law of sines is. So the law of sines, you do need to write this in your notes, is the sine of angle A over its opposite side, A, equals the sine of angle B over its opposite side, equals the sine of angle C over its opposite side. And again, just to reiterate, it doesn't have to be a right triangle. A, B, and C, capital letters, are angles. Those are the three angles there, and the three opposite sides are lowercase letters. So they're directly across. So angle, side B is across from angle B. And that's the law of sines. You got to know the law of sines. And we'll set that up for each triangle we do. This is not actually too bad as far as like the math of it. The calculator does some of the work for you, and it's all right. So let's try this one. So given this triangle, this happens to be called ABC, but even though it's DEF, the rule works. It's just sine of the angle over its opposite side. So I'm just going to go ahead and start with, one thing that's nice about this one, and you might see it already, is even though they only give us two angles, we kind of know the third angle, or at least could figure it out, right? If you get your calculator out, you've done this before. 75 plus 60 is 135. If we take 180 and subtract that value, we get 45. So 45 must be the other angle. So even though they only gave us two, if they give you two angles of a triangle, you can pretty much figure out the third. And that's what we're going to do. We're solving triangles. You got to figure out like kind of all sides and all angles here when you solve the triangle. When it says solve the triangle, it means find all the angles, all sides. We found all the angles. We're partway there. So now let's set that up. I'm going to use that because I really needed that angle to have relationship here. So it's going to be the sine. I'm just going to set up all three. So the sine of 75, which is your A, over its opposite side, which is a little a, equals the sine of b, which is 45, over little b, which is 340, equals the sine of c, which is the sine of 60, over little c. And so now at this point, you're just going to pick which two you want to try and solve. You want to kind of like solve one that's only missing one term. So like that middle one's really key because we've got sine of 45, we've got 340. So I'm going to pick like these two and make a proportion here. So I'm going to solve this one, and then we'll solve the other one maybe to find the other side, I guess. So to solve, you just kind of cross multiply here. I like to put the number in front. So instead of sine of 75 times 340, I think it's safer to put the number, the coefficient kind of in front, times the sine of 75 equals A, again, I put the number in front, times sine of 45. And you're almost done, right? We're going to solve for A, so we're going to divide by the sine of 45. And that nicely cancels, and you get that. And so then you want to go to your calculator, do your control divide your fraction template there. I see in the corner of my screen it's degree mode, which is definitely what I want. If not, you want to click that. It'll change the mode for you. 340 times sine of 75 over sine of 45. I'm going to put a decimal point because that will give me a decimal point answer, which is really what I want here. And in this chapter, I want you to get in the habit of going out 4 decimal places. So A is approximately equal to 464.449. If I mouse up, I'll actually see more decimals. Percent terms, so 4486 actually would be a better number there. Okay. So we have our 464. And just kind of make sure that makes sense. That does make sense. It looks like it might be a little longer side than the other one. That's definitely possible. If it doesn't make sense, you want to then if it doesn't make sense, you check your mode again. So to change the mode of your calculator, just click that button up there. So if I click, see how it changed to radian. If I click it again, I think it, oops, if you left click. So it's weird. Kind of, okay, so let's change it the other way. So if you can go doc, settings and status, document settings, change it to degree mode, and say okay. And now it's degree mode. Okay. That's weird. It should work. I don't know what that was. Okay, so now we're going to take 2 other proportions. So I would probably choose these 2 proportions. We're just going to solve that by cross multiplying. So it's going to be C times sine of 45 equals 340 times sine of 60. One step to solve, you want to divide by sine of 45. That nicely cancels. You get C equals, and this becomes a calculator problem at this point. And so we'll go control divide 340 times sine of 60 over sine of 45. And if you don't hit Control Enter, you won't get the decimal there. So we need the decimal, so that's going to be 416.4141. Let's go up one decimal place, 4132. 4132 would be the way to get that. Just in this chapter, I want you to take it out 4 decimal places. And so we've got all the sides and all the angles. We have solved the triangle. Let's try another one. So find the value of B. So this time we were given, kind of looking back at this, if you remember, like we were kind of given 2 angles and the included side. So we were actually given ASA. And this works every time you're given ASA. It's no problem. It's going to be a straightforward problem exactly like this. If you're given the angle, the included side of the angle, the other angle is easy to figure out. Once you get that, you do law of sines, you've got it. This, just to kind of state what this is actually, so a side, and the non-included angle. Be careful not to spell a bad word there. So I'm going to say side, and the non-included angle. So even though this might not be a congruence theorem, you can actually do law of sines in this case. We have to be careful. We're talking about why you have to be careful in this case tomorrow more specifically, but I think this one, well, let's see if this is straightforward. This is actually the case called the ambiguous case. So maybe this one gives us problems sometimes. So anytime you have what potentially could be a bad word there, you have a case, it's called the ambiguous case with law of sines, that you may run into some trouble. So let's see if we run into trouble. We'll start solving it like normal. Looks like, you know, I see an angle that's opposite side, so let's set that up. So sine of angle A, which is 47, over little a, because this is actually equal to little a, is 15. Let's go to sine of B, so sine of angle B over little b. We don't know either one, so that's going to be tough to solve for right now. And then sine of angle C over little c, which is 25. So interestingly on this one is I'm going to choose like this proportion and this proportion, and we're going to cross multiply those 2 guys, right? Because the middle one, we don't have both terms, so I need to find the angle first or something. So I'm going to cross multiply, so it's going to be 25 times the sine of 47 equals 15 times the sine of c. It's going to be an extra step I can only see to solve. So we're going to divide by 15. Divide by 15. This cancels, right? We get, I'm going to write it this way on the left-hand side. I just like it better. So sine of angle C equals a big fraction, 25, times the sine of 47 over 15. Okay, and the last step to solve, you probably know this, is to take the inverse sine of both sides. We talked about this yesterday with the right triangle trig. It's still true. So we take the inverse sine of that whole side, which is 25, times sine of 47 all over 15. Okay, so let's type this in. Now calculate problems, hit the trig key, inverse sine is right there. Control divide, 25 times sine of 47 all over 15. I'm going to put a decimal point because I want a decimal answer, and I get, big reveal, did I type it right? I think I did. Oh no. Okay. So if this happened on your homework, I don't think it will, but if it did, we're just going to table this problem until tomorrow. This is actually the ambiguous case. It causes problems sometimes when you have SSA, side, and the non-included angle. It is a difficult case to handle. That's why we're spending 1 full day on this. So right now, we're just going to throw up our hands and say, well, we don't know how to solve this. There's actually 3 different things that can happen. Sometimes it's unsolvable. Sometimes there's one solution, like a normal triangle, and then like it gives you no trouble. And then sometimes there could be two triangles. That's kind of the crazy, really crazy um, case that happens with the ambiguous case. So we'll talk about that tomorrow. So don't panic. I don't think it'll happen tonight in your homework, but if it is, make sure you kind of check and go, okay, if it's that case, we'll learn about it tomorrow, and that will help us. What's wrong with this triangle? So this triangle, well, I don't know if you remember your geometry. I wanted to ask you this because I could ask a question like this. I'm going to try to draw this to scale, at least the best I can. Side C looks like it's 7 units long, so that's 7. Side A is 2 units long. I'm going to say that's about 2. Side C is about 3 units long. This is about 3. The problem is, and you can probably see it now that I drew it somewhat to scale, is that doesn't form a triangle. Right. So the theorem I need you to know for this, because sometimes the book or me or the test may ask you like to solve this triangle. Well, one of the rules you learn in geometry is you have to add up the two smaller sides, or any two sides, which in this case would be the two smaller sides, and it has to add up to more than the larger size. So 2 plus 3 is 5. 5 is not bigger than 7. That's not a triangle. You would just say no triangle here. It's not even no solution. It's not even a triangle. And so that could be the answer to a problem. If I say solve this triangle, like you think, oh, I can probably solve this. You can't. It's not a triangle. Like would this one be a triangle? 5, 7, 12? No, because 5 plus 7 is 12. 12 is not bigger than 12. So the two sides are not bigger. So that's not. But if you had like 5, 6, 7, that's a triangle, right? We could probably figure out a way to solve that, especially after the law of cosines lesson. But 5 plus 6 is more than 7, so that is, in fact, a triangle. So be careful about problems like that. What's wrong with this triangle? Be careful. I'm trying to, kind of clue you in, like, don't fall for these kind of classic mistakes, because sometimes I could ask a problem like this. Okay, let's just draw it. Looks like it could be a triangle. So A is 92, B is 89, and C is 10 degrees. And what's wrong with that triangle? And so if you add these up, well, let's just try this. So let's see, 92 plus 89, 89 plus 10. Uh-oh, I don't think that's a triangle. That doesn't add up to 180, so you'd say no triangle on this one. So, just kind of pay attention to stuff like that, because it kind of actually affects when you're kind of solving, you got to pay attention to the angles, because sometimes you'll say, oh, there can't be a triangle here. And if you're not paying attention to the angles and adding up to 180, like really, even if you don't know this one, you go, oh, not a triangle, because those two are already more than 180, and you just stop solving and say, not a triangle. That's going to help you in this lesson. What cases does it work? So we talked about a couple cases. I think we mentioned the ASA case. Yes, you can. We mentioned the potential bad word case is kind of in the middle. It's kind of like, well, you can, but you got to be careful, and sometimes it doesn't form a triangle. We'll talk more about the ambiguous case then. Let's talk about this case. So if you have AAS, let's just kind of draw that out for a second. So if you're given, so I'm just going to say we're given, this angle is, 40. This angle is 60. And we're given a side that's not included. Like, let's say this is 10. Could we solve that triangle using law of sines? Well, we know this angle would be 80, right? Because 180. Now we could set sine of 40 over 10 equals sine of 60. Yeah, we could definitely solve this triangle. We have enough information because we have one full set there, and then we could solve for this one. And then once we have that one, we could solve. So this definitely does work. Law of sines works really nicely with given two angles, right? And a side, it's going to work out really nicely. Let's think about this case. So this case would be, so you've got like, a triangle, and say, this is, 40 and 60 and 80. The problem with this, if you think about law of sines, like we don't have any full ratio there. We don't know any of the sides. And we don't know how big the triangle is. It could be really big, it could be really small. We have no idea about the scope of this thing. So this is definitely one that, I mean, you can't really solve that kind of triangle. You need something about the sides. In SAS, let's just kind of think through that one for a second. So, so you have a triangle and you're given two sides, so 10 and 12, and the included angle like, 30 or something. So is that enough information? So you'd have, sine of the angle over its opposite side. Well, you only have one of that ratio. Sine of the angle over its opposite side, you have one of that ratio. Sine of the angle over that, you just don't have enough information. So we can solve this eventually when we get to law of cosines, but right now with law of sines, we don't have enough information. So really, given two angles in one of the sides, or the potential bad word information there, um, those are the cases that you might be able to do this with. That's it, I think, for the lesson. Great.